Alright, let's take a look at some of these that we seem to having some issues with. The first type of problem it looks like we want to look at is something like finding the sine of, I don't know, let's say 16 pi over 4. Okay. Well, 16 divided by, I don't want, over 4. That's too easy. 16 pi over 3. Now 16 we can think of as 5 and 1/3. So what I could really think about this as the sine of 5 pi plus a pi over 3. Now, consider the unit circle. And we start from the positive x-axis. And we want an angle that's 5 pi plus pi over 3 radians, or 16 pi over 3. Well, there's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and then pi over 3 more would be down here. Well, pi over 3 past pi would be the same as the angle 4 pi over 3, and what we want is the sine. Now we know the x-coordinates there are going to be negative 1/2, negative square root of 3 over 2. And the y-coordinate is the sine value. So the sine of that is negative square root of 3 over 2. Let's try another one. This time let's look at, how about the cosine of, how about 19 pi over 6? Right? I could think of that as the cosine of 3 pi plus pi over 6. Right? I add those things together with a common denominator, and I get 19 pi over 6. So again, I think about the unit circle. And I'm going to go 1 pi, 2 pi, 3 pi, and then another pi over 6. Well, there's the 3 pi plus the pi over 6, but if I looked at just that angle, that would be 7 pi over 6. And we know the coordinates of that point would be negative square root of 3 over 2, negative 1/2. Now this is a cosine, so what we want is the x value. So the cosine of 19 pi over 6 is going to be negative square root of 3 over 2. Okay. Now, the next one that we wanted to look at was to find the 3 trig functions for an angle in standard position, but it contained something like the point, I don't know, how about negative 3, 4? So what I would do is I would just draw a little triangle. And I would say, here's my angle theta. And if you want to draw in a set of axes, you can. Okay. Oh, and look at this, I even drew mine backwards. This is the point negative 3, 4. That means I went negative 3 in the x, and I went 4 in the y. Now, using the Pythagorean theorem, I can find the length of the hypotenuse, and I know that the length of the hypotenuse is 5, because this is our old friend, the 3, 4, 5 right triangle. Now, the 3 trig functions. The sine, the cosine, and the tangent. Now, tangent is opposite over adjacent, or it's 4/5. Cosine is adjacent over the hypotenuse, or -3/5. I'll write that so you can see it. -3/5. Now, tangent is opposite over adjacent. There we go. All right, we took the point and we made a triangle using that point. And then it's just a matter of remembering what the trig ratios are. Let's do another one. Let's find the three trig functions for an angle in standard position that goes through the point 7, 4. Okay. So I'm just even going to draw the little triangle this time. That's all I'm going to do. Here's my angle theta. I want 7 in the x direction, 4 in the y. Now, the square root of 65 is going to be the hypotenuse, 7 squared plus 4 squared. All right, so I'd have 49 plus 16, 65, and the square root of that. So, the sine is 4 over the square root of 65. The cosine is 7 over the square root of 65. And the tangent is 4 over 7. Okay? So, that is that. No problems there, right? Well, let's take a look. The next one we wanted me to look at was something like the tangent was equal to -5. And then we told you that the sine was less than 0. Well, let's think about tangent. Tangent is opposite over adjacent. So if I came in here, and again, I'm making one of my little triangles. There's my angle theta. Opposite, adjacent. But now they tell us that the sine is less than 0, so that means that the -5 has to be negative. Well, the 5 has to be negative. Now, the hypotenuse, square root of 26. 5 squared plus 1 squared is 26, square root of that. And we want to find the values of the sine, and that's opposite over hypotenuse, and cosine, which is adjacent over hypotenuse. Okay. Now that one was alright. Let's try another one though. This time, let's say I told you that the cosine of angle theta was equal to 2/7, and that the sine of this angle was greater than 0. In other words, it's positive. Well, I'm going to draw out my little triangle. There's my angle theta. Cosine is adjacent over the hypotenuse. Right? Adjacent, hypotenuse. And that means that the opposite side is the square root of is 7 squared minus 2 squared, so it's 49 minus 4, which makes this the square root of 45, and it's positive. because the sine, of course, is greater than 0. So now, the sine of angle theta is the square root of 45. The square root of 45 over 7. And the tangent of angle theta is equal to the opposite, which is the square root of 45, over the adjacent, which is 2. Stop. It's all right. I can pause.
I'm sorry.
That's all right.
I should know when you shut your door. See, that was the equation that I got from all this.
Yep.
Okay. Now, graph it and see. See? Now I changed it into... But if you look at where pi would be, and this is on a scale of 1, it's exactly what this is.
Right.
Why is it shifted pi and not shifted pi over 2?
Oh, because when that's in there, you divide the pi by that omega value. That's where you get... This is a value phi. The phase shift is that divided by that.
Oh, okay. Yeah.
Yep.
Okay, gotcha.
That's why it's pi.
Makes sense.
Okay. That's good.
Yeah.
It's good when things make sense.
Yeah,
Oh, hey, I didn't pause the recording. That was Mr. Wheaton here asking me a question about phase shift. That was fun. So, anyway, now that we had that little fun break, let's move on and look at the next type of problem that we had some questions on. Let's see. Oh, we want to graph some graphs and make... There we go. Okay. Let's see. Y equals something like 3 times the sine of pi times x minus, oh, I don't know, what should we have here? Let's go minus pi. And then let's go minus 3. Okay. Let's see. If we wanted to know what the amplitude of this thing was, it would be 3. The midline of this thing is negative 3. Now the maximum is we take and add the amplitude to the midline, and that would give us 0. The minimum we would take and we would subtract the amplitude from the midline, and that would give us negative 6. Okay. Now, period. It's always 2 pi divided by this constant right here. Okay. So for this one, it's going to be 2 pi divided by pi, which is 2. So the period is 2. Now the phase shift is this constant here divided by that constant there. So the phase shift is going to be pi divided by pi, which, amazingly enough, is 1. Now to sketch the graph of this bad boy. Okay. Here's a y, there's an x. Now my midline is negative 3. 1, 2, 3. Okay. 2, 3. Now, we shifted over 1 unit, so we're going to start here. 2, 3. And we know that we're going to end up there. We know that in the middle we're going to be on the midline because this is a sine function. Now, a quarter of the way through, we're going to be at a maximum. And 3/4 of the way through, we're going to be at a minimum. So now what we do is we would take and draw a very nice curve through those. And there's one period of our function. Okay? That was very fun, right? Good time. Good time had by all. All right. Let's see. Oh, I'm running out of time. We're going to have to stop here. What I'll do is I'll do the video part 2, and we'll start with another one right there. So hold on just a bit.